Okay, the fourth Java-related meeting in this Principles of Programming Graphical User Interfaces. This time will be start with this one. We will be talking about two main themes in addition to having some new components. First one of these is resources. So resources are all the other files except from the source code files that your program will need. So all sorts of icons and other pictures might be there, with some configuration files, plain content on the text files and so on. And these can go into the project. You don't need to load them from some external file or folder in the file system. You actually, in Java, can create a package for them, usually a separate package where the resources go. And we will see how you can put some images in there and how you can easily use them, but also how you can load them like any other file, so that then you know how to access any file from these resources. So let's see this in practice and then go back to the summary at the end of the lecture like usual. So somewhere here I have the NetBeans open, and let me create a new project. Yeah, let's do this. And I will now use packages this time. So if I just create a new JFrame form or main form for this resources and undo, because those I will be talking about, and let's add the package there. UTA where am I? Will be, and then I will add another package. Just do it from here if I do, and I just call that res, so it will be some of the main package name, but then just add that res. That's kind of the good convention how these resource packages are usually named. Now I want to put some content into my resources, and as you remember, all the packages are actually folders in the file system, so you could just put stuff in there directly, but in the NetBeans we can just okay, I think I have accidentally moved some stuff around. I can basically just go and drag and drop these files in there. So now I have a text file and an image file in my resource package. And then let's go and see how those can be used. The most simple way to use images is actually to use the JLabel. If you just drag and drop a JLabel into your application and then go to the properties of the JLabel. In addition to the text, you can notice that there is an icon here, and this icon can actually be any picture. And there's nothing to select here by default, but if I click on this tiny button here, I get this type of selector. Here I could just pick any file from the file system if I wanted to. But now I'm using resources, so image within the project, and then I just select the resource package, and there it is. I have a list of all the images. You can see the preview here. I click that, and OK, and then I just want to actually remove the text. So now I have an image in my application. That's easy and straightforward way to do and add images, so not much challenge in that one. If necessary, you can really rename these files in here, and there's a rename option and so on, so that your resources are well named. And of course, you can have multiple resource packages if necessary, and so on. So yeah, way to organize these resources. And then just a reminder from last time, we were looking at jar files, and when you compile the application, you get this one jar file. So all these stuff in these packages, all these resources go and become part of that resulting jar file. So you don't need to have a separate file where you distribute all this stuff. Then I can show you if I put another JLabel in here, and let's change the variable names. This can be car1, and this can be car2. Show how to load stuff manually from the resources. First, let's put the same image file, or maybe I should, let me just see if I can actually track a separate image file. Yeah, I have one here. Yeah, I have one here. I add another image file in there so that we are not beating ourselves. So now we have two image files there, and I will load that second image file, or set that image file into the second label here on the code level. So if you need to do it dynamically, for example, you can do it like this. To load the resources, you need to use what is called class loader. And class loader is very kind of in the heart of how Java programs are actually loaded into memory, and classes are not the memory, but we won't talk too much about that. It's quite advanced topic, but you need to use the class loader, and you get the class loader by first getting a class. So any class can, or any object can give its own class, and any class can give you class loader. So this is how you get the class loader. Let's call that CL, my class loader. We have this method called getResource. So this will give me a resource I want, and what I want is the phi uta gr.s, so the package name, in this case using the forward slash to separate the package names, and then I just give the file name, and this gives me, assign this value to a variable. You can see, and of course from the documentation you could see there's actually a URL which you receive, and using the URL we can then load the actual content. And what we actually need is some sort of icon, because JLabels accept icons. It was icon which we set, and luckily there is a file called image icon, both an image, and the image icon constructor accepts a URL. And then I can just say that scar2 set icon, icon. And now let's see what happens. Program, and there it is in the second icon. You'll see I didn't set the text to empty string, so that the default label is still there. But yeah, so this was set to the drop properties, and now this I loaded when in the constructor of the int components. Just set char to set text to empty string, so that they will now look the same. So here we are. Okay, that was the very first use of resources, adding images. Yeah.
Can you resize the images that you use as labels?
I think I would have to check that out if there is an easy way to do that, because
if I try indent it just crops the image
yeah.
without actually resizing it?
Yeah, I think that what's happened if you trying to control the size of the JLabel. Yeah, so it doesn't do scaling of the icon by default. So I think you would need to do that on the level of the icon. You would have to actually resize the icon or just resize the image before you create an icon out of that. So yeah, it's possible, but right now I cannot say that I'm sure which would be the optimal way to do that.
But so in code, is there something like icon set size? If I want to do that?
I don't think there is in this image icon.
I found this function get scaled instance.
Yeah, that's good call.
I think it's icon.get image and then get scaled instance.
Yeah, I think that's perhaps so this will get you a new icon, a new image, and then I think you can create a new image icon out of that image.
Okay.
And yeah, that looks actually, I think that's probably the easiest route to go through that. Yeah, of course, then you could just create directly an image out of the image file and get scaled instance of that and then create the image icon, but it's actually very easy to create that image icon out of that URL, so maybe it's even the shortest amount of lines of code, even though it's technically tiny bit unoptimal. But yeah, I think that's what you do. Actually, let's see what happens if I just try to do this. So if I just want to make this so these hints are probably something like whether anti-aliasing is used or not. Okay. So it's the scale, smooth scale default, so on. Should go into the last one. So image scale mode smooth get us a and get scaled instance. If you look at the documentation, returns the scale version of the image here and see and set image. Yeah, let's see what this one does. That's right. Oh, technically could go to one line of code. So image icon get image get scaled instance. new size, read height. Obviously, you would probably want to ask the current size to get the ratio so that it doesn't distort and so on. And then here is the image, in this case, and then I just set the image of the icon. Other questions? Then we can perhaps look at the reading another type of resource, in this case a text file. So I also added this car.txt into my resources. And I want that text to go into a text area, which is a component we haven't been using before, but it's quite similar to text field, except it supports multi-line text. So whenever your user interface needs to have a longer text for the user to display or edit, this is what you can use, or what you will by default use. And again, of course, the class loader, reusing the class loader we just got. And I want to get the resource. This time I want it as a stream. So stream, just like a file input stream we have been using earlier to read a file from the file system. So this is a similar stream, similar methods can be used in the similar processes. So this will look very much like reading a file from the file system, except now we first get it from the resources. That's correctly typed. We get the resource. And in this case, it's input stream, obviously, because we ask for the stream, text stream, and then I can create new input stream reader. So this is exactly the same as if you created a file input stream. So I can give here a text stream, and then I can give here the encoding. In this case, I think the file is UTF-8, and then I will wrap it into a buffered reader like I did last time I read a file. Allow NetBeans to add the necessary imports. Add throw, no, sorry, not throw, but try catch around there. And then assign the variable, return value variable, call that in, and then I will read that line by line. And while the line is not null, meaning that we haven't read everything in the file, I think I named this. I changed the variable name to description. Then actually the text area component has this append, so I can just append the line into the text file. I don't have to compile it separately into a string and then use set text. Saves me line of code there. And then obviously we have another exception. Well, let's just modify this a little bit. So there is this possibility for the IO exception whenever we try to read. So if I move that around so that both of these are inside the same catch for the IO exception. And yeah, I think I can just close also the input stream in the end. Okay, I need to do that, of course, also inside here, because that can also throw the IO exception. Now we get a few lines of text in here, and actually what I forgot to add that when you read using the buffered reader the file, line by line, it gives you just lines, not the new line characters in the end. So I add those back in. So you can get a resource or stream out of resource, which allows you to read the resource. So any type of file can be read from the resources, just it can be read from the file system. So you can put into the resources text files, but also, of course, stuff like XML files, JSON, even binary files, which you use your own code or some existing library to read. There are no questions. Right now, I think I will move on to the next thing. Few components we haven't used before. I will add into this one. First one is Spinner, and I can find it there. And this Spinner will be continue with the car theme, model year of this car. The information here, it won't be a very realistic application or anything like that, just adding a few, setting the name of the spinner to year, adding few components, illustrating different functionalities. Now spinner will look familiar, component as well. Okay, it's a little bit funny position, I will adjust the layout, but you basically have this possibility to move between the different numbers by these little buttons, but you can also type in stuff in there. Let's move this up a bit. Now, if we go to the properties of the spinner, we can find this thing model, which I have used a few times, and remind again that we will talk about models more in the future. So model specifies the content that can go inside the component or what kind of data it's handling. And if we click this button here, we can see that there are 4 different model types, or actually 3 different model types, and one of them is the default, which is actually the number type. So you can use this for dates. If I put it to the date, I can set the initial, minimum, maximum value and step size, so how much it moves forward. If we just run the application like this, there is actually one limitation. It doesn't exactly look like a finished date, so this doesn't fully support localization. Unfortunately, but we are not now looking for the date type. We just want one year number, so let's go to the model and select the, so the list would allow you to just set what are the items there, type them manually. We are interested in numbers. Our initial value is, let's say, 2000 and 9. Our minimum value can be like 1890. We can set the maximum value to, I will now just put it to 2010, and then the step size that every year can be selected. So now we have the spinner working somewhat reasonably. Still the layout, I think actually, because we are adjusting this component so much there. That's what then is messing up our layout here, but let's not worry about layout at the moment. Now we can go to the maximum year 2010, and then we could go back into the minimum value and move step by step. Now, in the code, you can also access the model and adjust it, and that is I will show next. So it's the year. It was the name of the spinner. I can ask it to give me the model, so get model, and by default it's spinner model. But if we set it to the number model, it's actually a spinner number model. What is the class? And this gives us the proper methods. I have to import, and then I allow NetBeans to do the casting. So we must explicitly cast it because it could be any spinner model, but now we know that it's the spinner number model because that's what I said in the settings, so I can rely on that and do the casting here. So now we have the model, and now I can set the maximum of that one. I want it to be this year, so now that whenever this program is run, it will be always this year, because that makes sense in this use case. Or maybe it should be this year +1 because the car makers tend to use the future model year numbers way before the calendar changes. How do you get the current year in Java? You actually use a class called calendar, and from calendar you can ask for an instance, and this will give you a calendar. And Java is actually fully neutral from the point of view that there are actually multiple different kinds of calendars in the world. So it doesn't assume the Gregorian calendar, which we happen to be using in this side of the world. But when I get the default, just get instance, it will give me the whatever calendar is used in this particular culture, whichever you have set into your computer's operating system. So now I have a calendar, and from that, calendar I can get stuff, and it actually has this method get, where you must give an integer which tells which field you want, and I want the calendar year. So this will give me the year number using the whatever calendar happens to be valid for or selected for our system. So that should be enough. Now we have updated the model, and the model is all the time in the background controlling how the component works. So now the maximum year should be 2018. Okay. Then I want something to happen when the spinner changes. So of course I could just get the value of the spinner based on some other event, but often you want something to happen when the user changing the value. For the demonstration, I just put in here a year label where I will update whatever changes here when it changes. If you try to double clicking it, nothing happens, so there isn't such a default event which would be like in a button. When you just double click, it creates the action listener, so there is no default event, there is no action event. If you look for that, you must go into the events list, and it's the state changed event which we are interested in. So this is fired every time the value of the spinner changes. Let's capture that event, and now the well, we can get from the year, and there is this value which we can ask directly from the spinner, but it can be anything, because there can be a different model. There can be that date model, there can be that number model, there can be a list model, or you can even, as we will later see, provide it your own model, which would provide some other type of object. So this is just object, we don't know exactly what it is, but in this case we can just use toString, and we can set that to the year label set text, and that should be enough. Now every time value here changes, it also changes in the label. Straightforward in a sense. There is one potentially interesting thing to notice here. I'm running the program. You can see that the number is immediately up to date, even though I haven't clicked any buttons yet. So what we can deduct from this is that actually the state changed was already called. So question is, why was it called, which caused it to be called? And it is the fact that we updated the model of spinner. So that means the state of the spinner changed, and that triggered the event. So this is a good thing to notice, not particularly maybe because of this application, but as a general note, whenever you in your own code do some changes in the components and change their value from your own code, it will also trigger these event handlers which are listening to relevant things like this state changes and so on. And in the worst cases, you can create infinite loops where your event handler changes the component, and then that triggers another event which is handled immediately in the same code, which will change the value, which will trigger yet another event, and then in practice that means that you get this recursive loop which will crash the program pretty much immediately through to the Stack Overflow exception. It's particularly easy. We will later look at this JComp. Well, I don't remember if we have more examples of the JCompo box, but if you are listening to those events and changing the values of the JCompo box, it's particularly easy to create those infinite loops. And later, when I show an example or the undo functionality into this application, you will also see that although it doesn't cause an infinite loop, it causes one extra event handler, I will show one way how you can handle and avoid those problems, or at least manage the case. Okay, then I will move on to one more component which I will add into my application, and this is a slider, which I can find from there. And yeah, just label for that slider. Edit text. I will have a slider for telling how much this car must have been driven. And if we go to the properties of the slider, we can find some settings, and here you can actually notice that things like minimum and maximum are available directly here. So it doesn't have a separate model compared to the spinner. So slider can be only be used to select the numbers from a logical level. Of course, then you can map those numbers in your application to whatever you want, but it's a more simple component from that point of view. I have here some sort of maximum, minimum can be 0. Then we can have this tick spacing, so I can add here 10,000, and well, you can have it horizontal or vertical orientation. I can ask it to paint those tick labels by make it visible here. You should be able to see updates in real time. And yeah, paint labels. If I put this much ticks, it's too much, but I can ask it to paint ticks. So these define where those tiny lines go in there. And you can also ask it to snap to ticks or not. And there can be a default value. Should be quite straightforward component to figure. And now it works. Of course, it doesn't do anything. I will do the same thing at the label. And let me just change the variable names here. Let's call it KMS, kilometers. Again, if I double click, nothing happens, so we must go to the properties and check out the events. Of course, as always, there are lots of them, but we can again find state changed event here. So this is triggered whenever some sort of change in the slider happens. And now we can, from the KMS, we can get value, and this is actually an integer. So linked to the same fact that it doesn't have a separate model, it's just always about numbers, it's always an integer. And text, just quick and dirty way, turn it to a string. And now if we run it, we should be able to see the layout is really messing up annoyingly, because I think this particular label, because we are doing that towards what are the boxes which create all these effects. It's not what I wanted, but at least now I think the everything will stay visible, and you can see the value changing all the time when I'm sliding this. So it reflects the change in real time, and not just when I release the slider. Of course, that is something you want to do sometimes. So especially if the slider or this update of the value is somewhat heavy processing, it could get really annoying for the users if the operation wasn't smooth. So I can, when necessary, I can check if the value is adjusting. So the JSlider has this method getValue is adjusting, and this is true as long as the user is still sliding the slider, and false when they have released it. So when it's false, then we know that this is the kind of the final value. So now when I'm checking for that, so obviously I want it not. So when it's not adjusting, then I would want to update the value. So now it's not changing, and then when I release it, then only then it gets updated. And you can also notice here that this label never gets updated like this one, which gets triggered from the, as I explained, from the fact that I changed the model. Okay, so there were two components which are reasonably straightforward and easy to use. Then I could go into the second bigger concept in the lecture, and that is doing the undos and supporting undo and redo functionality. I will first quickly just add us a menu bar and a few menu items, one in there and two into the default edit menu. So this can be undo, not uno. Undo item and redo. And quickly I will make this an exit button. Like usually did. Now, obviously, when you want to create an undo to your application, you must have some generic functionality which you kind of always have to handle. So basically, you must remember if there is some sort of undo thing you can do, if there is some sort of redo thing you can do. And if you think of those, there is a list of those. So every time you do something which can be undo, that goes kind of in the end of the list. And then if the user does an undo, you go back into this list, undoing the operations. And then the undone operations go actually into another list, which is the redo operations, which you can then redo. And then whenever you do some new operation, the redo part of the list is cleared. So this is what you basically need to do. You need to have in the application anyway, and anytime you do undo, and obviously most of the applications want to have an undo, so there is no surprise, I guess, in the thing that there is an existing class to do this in the swing, and it's called UndoManager. And just create a new UndoManager, so it's totally generic. And then whenever something undoable happens, you add into this UndoManager one of these undoable things, and then these undoable things are created so that they can actually undo the undo and redo themselves, so that then you just call the UndoManager to do the undo and redo. Let's first implement the functionality into this undo and redo. So now that we have the UndoManager, these are super easy. Basically, you should always first check that if UndoManager can undo, then the UndoManager undo. And exactly the same thing in the redo. If the undos can redo, then we let the undos redo. And obviously, in well-designed application, you use this can undo and can redo to enable and disable the buttons or the menu items as well. Yeah.
You use can redo in both of them.
Okay, yeah, that's good. Good catch. So this should be can undo. Undo and can redo, yeah. Obviously, thank you. Of course, this doesn't do anything because we haven't told the UndoManager which things to undo. So I want now to undo these slider changes for the kilometers value. And okay, here we are about to do the operation. So what we need to do is to add what is called an edit, UndoableEdit. And well, first I will get the old value. So because when we are undoing, we want to, of course, go back to the old value. I just put it into a variable right now. I get that in this case from the kilometers label. So obviously we have in that label the old value which we want to go back to. We could also get it from the slider directly. Well, yeah, of course we could at this point get it from the slider directly because we haven't changed. Oh well, actually, we couldn't get it from the slider because slider is at this point it's adjusting, so we would want to remember the old value, and we still get that old value from the label. You could possibly in some cases want to store it somewhere, but in this case at least we will easily get it from the label. This is the old value we want to go back to once something gets undone. Now the undos we can add edit, and it must be what is called an UndoableEdit, and there is this abstract UndoableEdit which we can use, and so I'm using the anonymous class notation here. Put a new line in there, and we need to import the abstract UndoableEdit, and then there is also return value, but that's not necessarily right here. But if we just have a quick look at the documentation, constructor implementation of UndoableEdit, implementing simple responses to all Boolean methods in that interface. So this actually implements everything. There is this handful of these things in here, and you can see that there are things like undo and redo and get presentation name. These are the most important ones, and these can do, can redo, can undo, and some more advanced ones. What we need to implement here is the undo function. So we need to override that method. This add notation at override is it's an optional notation, so you don't need to add this line, but it ensures that we are actually overriding something. If we wouldn't be actually defining a new method which isn't coming from the parent, then this would give me a warning that, hey, you are not actually overriding, even though you are saying you are overriding. So the public void undo is the thing that we want to now implement. This is an extra one. So we want to implement this undo, and in this this method you should always call the super undo, because that takes care of all this bookkeeping of whether this was undone or not, and whether we can go back and so on. And then we just need to do the actual undoing. So we into the KMS label we set text, and we put there the old value, which we picked into this variable, which in the modern Java it stays there. We will see that value in this code, so we can use it directly. And then we want to put the sliders set value, and we want to pass the old value into int, so we can set it in there. And this should be enough to undo. So this will be called whenever the UndoManager wants to undo something. And let's see if everything now works. So I will adjust this a couple of times and then undo. And yes, we can see that it undoes, but actually what happens here is now that, well, now we get to the very first one, and because the initial value was JLabel 13, that gets stored into the very first undo value, which we want to go back. So obviously that fails. So we should probably have a check if we have a number format exception, but of course this value could also just be made to start from 0. Yeah, as said, I move this once, twice, 3 times. I set the undo. First time it moves, okay. Second time nothing happens. Third time it moves, okay. Nothing happens. Fourth time it moves, okay. And then nothing happens. I think at this point is saying cannot undo anymore, so can undo is false. But what happens there? Why do we get extra undo steps which do nothing? This is exactly the same thing I mentioned earlier on. Whenever we do this, set value in the kilometers, that changes the state of the slider, and that triggers the state change, which comes back here, which adds actually an undo at that moment. And why don't we get an infinite loop? Is that because it comes here the second time, the value we are setting to the slider is actually what is already there. So because the value is the same, then the state doesn't actually change, and that's why we avoid the infinite loop. But of course, we don't want even the one extra time of doing this. So one sort of a trivial way to do this is that we just remember if we are undoing or not. Let's add here a variable, boolean undoing, and by default it can be false. UndoManager, so it's a class level variable. And then I can just check here. That we only, well, actually I don't want to put it here. I still want to do this part, so it's only this undo part. So if not undoing, only then we go into this segment here. And when we go in here, we just do so that we set undoing is true, and then when we are done, we say undoing is false. So now that when we get here the second time, we notice that we are already in this undo thing, so we shouldn't add another undo, and that's we just skip that part and we just change the value in the slider. And from that point, you can actually, with the current implementation, actually setting this one is unnecessary because it will anyway, this will trigger anyway this state change, which would change the label value. But yeah, I just leave it there. Let's see if it now works. So 3 adjustments. One. No, it's still doing that. So, oh, sorry. So this, obviously, this shouldn't be here. It should be here. So now we are, in this point, we are undoing. And, now, hopefully, everything is where it should be. 1, 2, 3, and then nothing happens. Yeah. So this part, when we are actually undoing, we tell that, okay, we are undoing. And then once we have undone, then we tell that, okay, we are no longer undoing. And then when this gets fired, we check if we are undoing or not, and we change that. Change only the label if we are undoing, but if not, then we are adding an undo step. Okay, I have the redo in the menu, but that doesn't right now do nothing because we haven't implemented the redo. So basically, we should do the redo thing as well. So, but I think this is quite straightforward. So you get the new value similarly, and then you put a similar method called redo in there, and you actually put the values into the redo. And for that, you can also, well, you use the undoing variable to avoid also that creating the new undoable steps. There will be there is already in the Moodle one pure Java example, which is very, very, very simple. I quickly run it here. tiny one, you can just click button to add characters into this in here, and then you can undo and redo. And uses UndoManager similarly. Super simple layout filled with boxes. Just have those buttons. And then in the action form for the button, the add label, it creates this character addition. And it just goes into the UndoableEdit. So this is what actually does all the actual functionality. And if you think of an average like editor type application, actually the undoable edits are your kind of the heart of your application's functionality, because those are what modify the document. In this case, this is very simple. I have this character addition, so it implements this undoable edit. It doesn't use the abstract one, so it actually implements everything for the sake of example. The character it has added into the label, and it has the label, access to that label, so it can actually change it. And in the constructor, it just picks that random character, which it will also remember, and then it sets the label text in the label to be the current text plus C. It remembers the label, and it remembers the character it added. Are these methods which you, in this one, this add edit, which is very like advanced functionality. So in some applications, you can think of the edits to need to be sort of hierarchical. So if you are typing text, for example, in the text editor, you might want to bundle it so that the first individual characters can be undone, but then when a whole word is edited, then the whole word is actually undone with just one undo operation. So this is for those kind of advanced functionalities. Add edit and replace edit. And there is this get presentation name. You can return the name, which then in a separate part of your code, you can ask from the UndoManager to get the undo presentation name and redo presentation name, which you can directly put into the menu item, for example. So you can separately return this undo and redo presentation name, and then at least when using the abstract class, this actually it's enough to implement this one, and then it will put the undo and redo words in front of those. This can undo, can redo, where you can just usually return true in trivial cases. There's this die method. If you reserve some resources here, you can free them. It's significant is related to the more advanced functionality. And in the undo and redo, in this case, they are very simple to redo, does the same thing as it actually originally did the thing, and undo just takes the last character out of the current text of the label. Yeah, so this was an overview of how the UndoManager works and how you can add undo into your application, which becomes relevant when you have more complex application with more complex operations. Of course, users assume that there is undo in their applications, and well, you get the very basic stuff like when you are editing the text, you can still undo that without you doing anything in your application. But anything more complex where you are actually managing the content, then you need to take these steps, which are not necessarily massive, a couple of lines of code, and then you get the proper undo functionality. And just remember that, yeah, the UndoManager, you can add any type of edits there, so you don't have to worry about that. There are lots of different operations in your applications. You can just put all of them into UndoManager as long as you just think of separately each of the undos. Okay, then there is one more concept I want to discuss, and that's drag and drop. If we run our application, you can see that in this text area I cannot drag the text. If we go to the text editor and drag and drop text from there, you can see that it works that direction. Text moved from here to there, but I cannot drag from here to there. So if you want to enable that, that's super easy. It's just one property, which is lower in the list because it's not one of the key functions. So here is basically drag enabled. If you add this checkbox, I can now drag into this direction. So yeah, text components, that's the thing you can do. Then if you want to support more custom type of drag and drop, you can do that in your code. Let's add possibility for the user to drag a file into this label, an image file, so it will change that image file. I will go again here into the part after the init component, so into the constructor where I have been doing all these other things also during this lecture. Here in the end, I will add this code, which will implement the most basic support for the drop part of the drag and drop. That is called DropTarget, so I will create a new DropTarget. And first parameter here is the component where items can be dropped. And second one is drop target adapter. So I will create new drop target adapter using the anonymous class syntax here. And now this imports we need to put in place. And now I can ask NetBeans to implement all abstract methods, and we can see that there is one abstract method I need to implement to make this supported, and it's drop. And what needs to be in drop is quite a few things. It's not complex by any means, but it can look a little bit messy because we need to check for a couple of things. You see that the drop method receives a drop target drop event object. And this object basically tells us all we need to know about what is being dropped into this object, and it also gives us access to actual data of that what is being dropped. The first thing we need to do is check event. We can ask is data flavor supported? And well, NetBeans already by default fills in here data flavor, image flavor, but this is actually not, it just randomly picks the first flavor it finds. It's actually not image flavor we are interested in, although that might sound correct that people are dropping images, but actually if they are dropping an image file, it's a file list type of image data flavor. So it's this Java file list flavor. So if it's this flavor of data that is being dragged, then we can actually, well, this is what we will be working on. But first, I say that if this is not true, if not data flavor supported this Java list, Then what I will do, I will reject the drop. So in this same event object, I can say reject drop. Okay, I will not accept this type of dropping. If it is the correct type, the file list type, file list flavored dropping operation, I will get that. So from the DTDE, I can get what is called transferable. Transferable is the actual stuff, and from the transferable I can get the transfer data, and there I must give the flavor what I want. So this is again the file list flavor, and this basically well, there is this try catch need here, so there can be unsupported flavor exception and also IO exception at this point. And let's put this into a new variable. This is object at this point, so the get transfer data is purely generic, but of course, if we look at the documentation for this Java file list flavor, we can see that the documentation promises that it is a type of Java util list, and it's guaranteed that the items are files. So what I can actually do here is that say that it's list file. And I think files, and I think there is need for the import of those two things. So both Java IO file and Java util list. Notice that it also recommends me Java AW2 list, but that's not what we want. It's Java util list, and then we need to cast that explicitly. So now we got actually the list of the files that were dragged into this location. And then I can basically just use those files, assuming that there will be just one file, or if there are multiple, I will just use the first one. So now I will set the icon of the one into the image icon, basically what we did in the first part of the lecture. And I will get files, the very first file, get 0, and from that there is this deprecated method to URL. You remember that we created the image icon from URL. We should not use the deprecated method. There is this to URI, and the URI has method to URL. We need to link these together to actually get the URL. That's almost all we need to do. There is just one thing which I want to do here first. So DTDE accept drop. Here I should tell what sort of drop I'm accepting, and these are defined in transfer handler named class, and it's the copy action I'm taking here. So the file stay where it is, but we will just use it here. It can be also move, and there's some other type. So that basically should be all. Looks quite complex method, but like most of that is well, exception handling and things like that. Very few lines. We just check if this type of data flavor we are interested in is supported. So if the tracking object is correct type, we accept the drop, and then we get that actual transfer content there. There might be, it's possible, and the API is built so that one track might be multiple flavors. So it might in some cases be available as one type of or another type of content. And well, obviously you can find some different flavors and so on if you look at the documentation. But this should be everything we need to do. So let's try to run the program first. And I had see if I had, for example, here I have some React logos here. Yes, so now if I drag an image here, we get different logos updated in there. So, well, you can see that when I'm dragging here, there is this next to the cursor, or the cursor has this marking that, okay, dropping here is not allowed. The moment I go over this component, it changes into this move icon so that I can drop in here. And then when I drop at this point, the event is called. So how the swing knows that, okay, the dropping here is possible is because this drop target has been created for this one. So this enables the swing to let the operating system know that, okay, something can be dropped here, and then the operating system can change the icon. And then this is called the moment I drop, and then I check there if it's a files that are being dropped. So let's see if let's take the text editor and drag some text from here. Again, we get some icon. Isn't actually the moving icon, but then obviously we do nothing because it's the wrong type of thing. And you may remember that if I dragged in here, it actually moved the text. It disappeared from here. But you can also notice here that it's basically rejected because at that moment the flavor is not correct. This is some sort of text flavor, which I will receive at this point. So only the files are accepted. This is taken care of by our flavor check, and yeah, then we just access whatever is the track content, and then we do whatever we want with that. And we also remember to tell that, okay, we did actually accept this drop or rejected it. So either one of these should be called in your DropTarget adapter. If you want to go deeper into this, I have in Moodle this program called AcesUp, which is implementation of this AcesUp Solitaire, and basically this is implemented using drag and drop. So well, it supports both drag and drop, and basically the rules of the game are implemented into these drag and drop operations. So it checks whether this can be drag and dropped here, and following the rules of the game. It's quite complex program, so I'm not assuming everybody to look at it, but just mentioning that it is there. Quite a lot of code in this one, partly because it also paints all the graphics using the graphics command, which we'll be discussing next time. So you can paint custom graphics. component is handled there. But if we just have a quick glance at the actual drag and drop stuff here. Utility class here is a drag listener, which allows us to change the cursors as we go, and here you can see that we get doing exactly the same here, getting the transferable, but in this case what we get there is actually this card class I created. So when you are tracking within the application, you can, the transfer content can be your own classes which move around in the application. Yeah, there is creating here also these transferables. There is this methods like can import and so on, and there is this transfer handler class which is used when you're doing both directions of basically transferring information to drag and drop. Chapter there and the stuff there. But I think I will leave this example to this brief mention. And maybe ask if there are questions about this, any part of this example we have been building. There is a version of that in the Moodle already, but with tiny differences. Let's see if I will clean up this year's version and make that available. Basically the same application, but tiny variations on how it was exactly implemented. So if we just summarize things covered, resources, we started with this one. So there are ways to add, for example, pictures, configuration files, content files, and so on into your application, and they go into the build jar file. And basically you just create a package where you put stuff into, you can drag and drop them into the NetBeans from the file system if you want to, or just put them manually into those folders. Images you can most easily use by just putting them into JLabels. And using the class loader, you can load any file as you get a stream to that file, and you can read it like any file could be read. Looked at the spinner and slider, and they both have the state changed events. Spinner, you can get the value which is object, because different models have different data types. But slider is always just integer-based numbers. We looked at UndoManager, which manages the undo and redo operations so that you don't have to take care of that list of operations, and quite straightforward thing to do, but it doesn't make sense that everybody implements that same thing themselves into each and every application. So UndoableEdits go into this UndoManager, and usually you can do that by just extending the abstract UndoableEdit and implement undo and redo, and also correct presentation name is something you usually want to implement. And then those edits must actually be able to do the undo and redo, and in more complex systems you can also make it so that tinier undoable operations are summed up into more complex ones at some point, and so on. And the manager takes a case of bookkeeping, whether undo is possible, redo is possible, and which exact operation should be undone or redone. And provide also access to those names of the current operations. So if we look it from the higher level, so of course you have the user interface. User is something that causes an event. It goes to your event handler code. Your event handler code, if it's such operation that it creates something that can be undone, then your code creates this UndoAbleEdit and adds it to the UndoManager. If it's undo selection or redo selection, then your event handler can just use UndoManager. UndoManager keeps track of these undoable edits, and these undoable edits do applications to the application data. Also, you can of course directly do it here at the same time that you are doing the undoable edit, but it's of course possible to remove this arrow directly, at least when it comes to the editing operations. So you can, when you create the undoable edit, you can already ask it immediately do the thing it does and then add it here. So it's only the undoable edits that would be actually modifying the application data. The plain Java example I quickly showed did it this way, so that whenever the undoable edit was created, it did the original thing and then the undos and redos. But the example we built directly changed this, but then just added this undoable edit into the UndoManager. And reminder that code can trigger events, so whenever you are changing the value of a component, if there is listener listening to that change, it will fire exactly the same as when the user operations trigger those events. So for example, if you remove all items for JCombo box and you are listening to the user selection changing in the JCombo box, you will also get a call to your event handler whenever you do yourself remove those items. And yeah, there is this thing called document behind the text components, which is the model of the text components where you can add listeners, and those are triggered whenever you modify the text or the user modifies the text. And in the JSlider, which we saw today, change event is fired whenever you set the value of the slider yourself. So it's quite easy to write a code where you end up in the loop, or in this case, for example, today we just got one extra call because we were a little bit lucky, but still, of course, there was a problem. So you should somehow know whether this call comes from the user or from your own code. And of course, it's easiest to maybe handle it so that whenever you're doing some things in your code which triggers events, you somehow keep that information up to date to yourself so that your own code can avoid doing things. Of course, there are a couple of different things you can do what we did here in the code. So I just had one Boolean variable telling whether I'm editing or not. Another approach would be to actually remove the listeners for the duration of your own operations. So you can add and remove listeners, and you put them in there, don't have to be there all the time. So in some cases, that would make actually a cleaner and easier to understand program code. And we look at the drag and drop. So many Swing components have drop support by default. Some components support drag, but main design needs separate enabling. And then you can implement custom drag and drop and also copy and paste support. So people can also copy and paste from other programs to your program, and the other way around. Your program can copy data into the same clipboard that every other application is using, and then it's the same basic functionality. So these data flavors are used and so on. So the basic Same basic functionality both for drag and drop and copy and paste. And yeah, we looked at how to do the drop support, which is quite easy to do. Comprehensive support can get rather complex, as you can see from the AcesUp if you look at it. But the drop target is quite simple. You just implement the drop method, check that the data flavor is okay, accept the drop, and then do whatever you need to do, or reject the drop if you cannot work with the data that was dropped. Of course, in this case, for example, what we did, we didn't check that if the file that was dropped was an image file. So obviously, we should check that if it's not an image file, then we should also reject the drop. And yeah, the transfer handler is the class for the more complex drag and drop operations when the drop target isn't enough. I think that's everything. Next time we will look into the custom components and painting in particular. And I think everybody knows that because of the Easter holidays, we won't have exercise meeting this week or lectures next week. So it will be next week's Thursday when we see the next time.
But the deadline for the exercises is still Thursday?
No, the deadline is next week's Thursday. It should be always before the actual exercise meeting. So you have plenty of time to work on these exercises, or of course the next exercises are already available. So you can, if you have been working on schedule, you can move on to those. Okay, thank you.